to understand impulse momentum theory. So we have a 0.4 kilogram ball with initial velocity 30 meters per second, move to the left, bouncing into a wall, and the rebound. The final velocity is 20 meters per second, pointing to the right positive x direction. We want to find out the impulse. And then from the impulse, if we know the contact time, we find out the average force. How do we find the impulse? Now this problem didn't give us force, didn't give us time, so we cannot use F times delta t to calculate the impulse. But this problem indeed gave us the initial velocity, final velocity, and the mass. So I can calculate what's the initial momentum, what's the final momentum. So we can calculate the change of momentum, right? And if you calculate what's the change of momentum, the impulse momentum tells you this is impulse. Okay, so we can find out what is impulse. The initial momentum of the object, so let's calculate. 0.4 kilogram m times v initial velocity, and the initial momentum is negative because P1 is pointing to the negative direction. Initial momentum 0.4 times negative 30, so it is negative 12. And the unit is kilogram meter per second. And then we need to find out what's the final momentum, right? We know the final velocity is 20 meters per second, so it's m times v, give you a final momentum, which is 0.4 times 20, give you 8 kilogram meter per second. So what is the change of a momentum? So it's not 12 subtract 8, or it's not 8 subtract 12. You see, your final momentum is 8. So its final momentum subtract the initial momentum, and the initial momentum is negative 12. So it's 8 subtract negative 12 gives me 20 kilogram meter per second. And the impulse momentum tells me impulse just equals to the change of momentum. The impulse equals 20 kilogram meter per second as well. Now I do know the time of contact is 0.01 second. So F average times delta t give you impulse, and I do know F delta t, I do know impulse, so I can calculate average force is impulse over delta t, 20.01 Newton, give me a 2000 Newton force. So the change of momentum is 20 kilogram meter per second. But because of the time of contact of the ball on the wall is small, is 0.01 second, so the force action is not, the average force action is not on the ball. So in the next video, we're going to talk about momentum conservation and collision. Thank you for watching. See you next time.